Hey guys, back again, part 2. Again, my name is me, the date is today. Okay, so now we're talking about restrictions. So, given the function f of x equals square root of x minus 6. This would be easy, but you obviously don't know that yet. The domain will be defined as long as the function under the radical is non-negative. So this x minus 6, if that's less than 0, then we'd get an imaginary number. So for instance, if we have, let's just say this was just, that gets us I, and I stands for imaginary, which sounds so lighthearted but is extremely hard to understand. So we're avoiding that with functions. So the radicand, y minus 6, needs to be greater than, that was not enough space, or equal to 0. So we need to set this greater than or equal to 0. So we know our equalities, inequalities. So greater than or equal to, and y minus 6, our radicand, and 0. So now what we need to do is solve for y. So you simply just add that to the other side. Don't forget to write your steps. Do not skip this. Not allowed. That will get you penalized on any test. So you must show that you added 6 on both sides to get where you are at. So now we can find the domain. So the domain, since well, it clearly states that y, or our value, needs to be greater or equal to 6. So this, like I said on the last sheet, is included. It includes a certain number or value. So we have 6, right? Because it can be equal to 6. And we have until infinity. You add your parentheses, and yeah, so that's your domain. It's quite simple. So now we move on to the other restriction, which, well, more or less confusing. But given the function f of x equals 6 over 3x minus 7, the domain will be defined as long as the denominator of the function isn't 0. If the denominator of the fraction is 0, then the quotient will be undefined. Like I explained in part 1, right here. Any quotient here, yeah, right here. Any quotient in the denominator or the denominator of a fraction gets you 0. That's just an automatic rule. So we want to avoid that when finding the domain. So here, the denominator, 3x minus 7, cannot equal 0. That's a fact that will always remain. So now what we need to do is set this up like again. We need to send our inequality. So 3x minus 7 cannot equal to, remember the signs, remember these signs because they are important, equal to 0. So now we just solve. We add 7 to both sides. This will be 7, 3x, and then 7 over 3, which is roughly 2.3333 to infinity. So now what we need to do obviously is find the domain. So it's so this is all real numbers. All real numbers. That it was not mentioned in here, but if you have a fraction and you're finding the domain of the function, it will be, like I explained over here, you have in the function over here, we have an opening at 0, or it can't include 0. So the domain in this function would be negative parentheses, or negative infinity to 7/3. Now you can put that in decimal form or fraction. I'm keeping it in fraction because it's easier to understand. And you have your parentheses. And like I said, it's all real numbers. So you'd add another parentheses from 7/3 to infinity. And that is your domain. So now we know about restrictions, and in part 3, we'll get to learn how to find them in different situations, harder functions. So, yeah, math is fun. Again, let me write this at the top. I swear, if I hear anybody say that math isn't fun, I'm failing you.